How you doing? Looking at 2020 question 5, part B. This is the one on the page in front of you here. If you haven't got it, maybe you should pause it and try it out yourself. Quickly, we have a mass M1, which we call ball P, and it's travelling at an angle of 30 degrees to a line that joins the two centres of mass 1 and mass 2. And then that's its initial condition. Q isn't moving when at the time of the collision, but it will afterwards. So that's okay. Then it says the coefficient of restitution is E. Prove that P will turn through a right angle if 4m1 is equal to 3e minus 1 times m2. This is my version of the solution. Of course, need to draw it out. There's not a lot to draw on this. The two masses, m1 and m2. Drawing U in at this angle 30. By doing that, we should be able to figure out the initial conditions of this ball. We do that down here. This is a table of data which we might use, which we will use. Very good to do for collisions questions. So this is the initial conditions, the initial speeds of the ball. This is the masses, and this is the velocities. In this occasion, M1 and M2 make this question a little bit different, but this is the same table that you should carry out as often as possible. So stemming from that's fine. The question says that prove that P will turn a right angle if 4m1 is equal to 3e minus 1 m2. That's fine. That kind of says that we can stick m1 into the equations later and just reduce it down to m2, and that will give us a mass that we can cancel. There is another way of looking at this, and I just thought the reading of the question was a little bit obscure. There is a little note to be made that the slope of two perpendicular lines which are travelling at 90 degrees to each other ends up in -1, and that way if you can find the slope of m1, you can find the slope of m2 because it's -1 over m1. Okay, so that's an aside, I suppose. In all collision questions, you get 5 marks for doing your conservation of momentum, and a further 5 marks for doing your NEL. You should end up with this answer, that 2m1p is plus 2m2q is equal to root 3 um1. You do your NEL, the same thing. That's your formula here, and that should reduce to 2p minus 2q is equal to minus 3ue. Try that out yourselves. There's not much point in just waiting for me to do it. So this is one solution, and that's if P rebounds at 90 degrees, then the slopes are the inverse of each other. But I'll just have a little look at what I think the examiner wanted. What happens if 4m1 is equal to 3e minus 1 m2? Well, that means that m1 is equal to 3e minus 1 over 4. This is the conservation of momentum. This means I can put this m1 in here. If I put m1 in as this will change m1 to be in terms of m2, change m1 to be in terms of m2, and I have m2 in all 3 parts of this equation, and so I can cancel them out. So why am I looking to solve for m1? Why not make the mistake for m2? And it would have been a mistake. We want to find P. We want to find the value of P because that's the one that's going to turn. It's only this P ball we're worried about. We don't care how fast Q goes that way. We're just dealing with the direction of P afterwards. So to do that, we want to get rid of this term, the m2 term. In order to do that, you want to express everything else in m2s, and you'll see why that cleans up. So subbing in this m1 into m1 and m1 here, we end up with this, and you should do the maths out. I did it slowly. You pause this video, see how you're going, try and follow, and it continues on to this. So it's root 3u times 3e. Put brackets on that. 3e minus 1 is equal to 3e minus 1 over 4p plus q. And then your NEL, when you rewrite it and you just divide it by 2, I end up losing my q's. So that means I'm going to solve for p, a little bit more maths, and p turns out to be minus root 3 over 6u. Okay, happy with that? That's the velocity of p. That's going backwards, it's negative. It's not going back so fast, it's root 3 over 6. You can use the tan formulas. You could find the slope of this line. I just decided to do something else. So the slope of this line, which I would have called M2, I know that's confusing with the mass, is equal to the rise over the run. So that's u over 2 divided by minus root 3 over 6 u. So u's cancel, so it's a half divided by, and that will give you the slope of that line. And again, if you could have gone 1 over m1 times 1 over m2 slopes is equal to minus 1, that would have proved it. I just decided to do it a little bit differently, and that was just to find this angle. Like, I think that's a little bit more simple, more straightforward for any of the students that wouldn't be too confident with being able to dig back into their maths for this. So you just find that angle. It's u2 over minus root 3 over 6. I'm missing a u out of this. That has to be a half. Anyway, so that's a half over minus root 3, which turns out to be 60 degrees. And that means, because it was going up at 30 degrees here, and I add 60 more, well, that makes it a right angle. And I hope that's pretty evident. So, and I hope that's kind of happy, and I think that's the way the examiner wanted to show it. Just the opposite of this would also be true, and it was maybe a different way to find p. And that's why I do wonder whether I don't believe this is the right way to do this question. But I think the way it was phrased, I don't think you would have been too far off the mark. So m1 was equal to sine 30 over cos 30, which gave us a half over root 3 over 2, which is 1 over root 3. M2 was going to equal minus root 3, because that's the negative inverse of 1 over root 3. So if M2 was equal to that, well then, what was M2? Again, I just discussed that in a moment ago. Slope. So that's the rise, which was u over 2. Why is it u over 2? Because there was no collision in the j component. So that's the same as it was when it entered the interaction. And this here will be p. So now all of a sudden I have quite a simple phrase here, and I can reduce p down to minus u over 2 root 3. Bring that into your NEL equation, and you can solve for q, and q turns out to be u over 1 plus 3e over 2 root 3. It is then, when you take your q's back into your COM, you were now trying to solve for m1 and m2, and so by putting in, you got u's across the whole way, so it turns out to be 4 is equal to 1 plus 3e m2, and that is what you were asked for. So two ways of doing it. Whatever makes you happiest. I suppose the first one is the way it's supposed to be done.